following footage was filmed by Dan Trockey, sales manager for Sign Pump's Chicago distributor, W.J. Wadsworth and Associates. The test was run at C. Doring and Son Incorporated in Westmont, Illinois, with the objective of determining whether the sign pump could handle an extremely high viscosity silicone product in conjunction with a screw feeder manufactured by Doring. Judge the results for yourself.
So thick, the gentleman has to pull it out of the tank with his hands and put it into the auger. Okay, here we have the product coming out.
Oh, wait.
That's 8 million centipoise.
Dan was invited to run this test for Sign Pump because the leading brand of external circumferential piston pumps, better known as rotary lobe pumps, that Doring's customer had been using sheared the product so heavily that its temperature was increased almost 100 degrees Fahrenheit. What was the temperature increase using the Sign Pump? Well, let the customer tell you.
The temperature increase is about 4 degrees, roughly.
You can see we're pushing about 100 psi with only about a 3-foot section of pipe in one elbow.
The pressure gauge is vibrating slightly because the operator is having a hard time supplying enough product to the feeder, which in turn is delivering pockets of air to the pump. Normally, the pulsation-free sign pump would leave the gauge totally still. Most processors would consider a product this viscous to be unpumpable, but that was before the sign pump came along.
The temperature rise pumping this product is about 2 or 3 degrees Fahrenheit, which is really negligible. And that is due to the very low shear of the pump. The amperage pull on the motor was read at about 4.8 amps, 3-phase 230 volt, which equates to about 1.2, 1.3 horsepower, which is a very small amount of horsepower for this viscosity product.
Amazing, but Dan wasn't quite through with the day's testing. In the following sequence, we see another difficult product combining the problems of both viscosity and sensitivity to shearing.
Okay, this is our next test. This is potato salad. We've got nice, about 1/4-inch cubes of potatoes. Okay, this is before the product is being pumped. We just want to give you kind of an idea what it's going to look like. The pump is going to be fed by the auger, and the pump will pump this material with very minimal damage.
In this test, the customer needed to improve the end quality of his prepared potato salad. We'll let Dan tell it as it happens.
We only got a little bit in there, so it shouldn't last too long.
Extremely low pressure.
Shouldn't be any pressure at all.
Virtually no pressure.
That's very good.
All right. Hey, Bert, why don't you bring that sample over here? We'll get a close-up on it. How's those chunks look? Got nice chunks, very similar to the product that went in. Pretty much the same as going out. There's very minimal damage. Nice clean chunks. You couldn't even tell the difference. Okay.
Where's the after?
We got a before and after shot of potato salad. You probably can't tell the difference, but the product on the left is the before, and the product on the right is after. And I'm going to zoom up on these. Okay, there's your before shot. I don't know if that can focus or not. And here is your after shot. Chunks are still intact. Very, very little damage. So if you got a product that you don't want to damage, there's one pump in the world that's best suited for that, and that's a sine pump. And there it is again, before and after.
That's it. 2 successful tests in far different materials no other pump can successfully handle. What is your pumping problem? Viscosity? Shear? Pulsation? Suction lift? High maintenance cost? The Sine Pump may be the solution for you too. From Sine Pump in Orange, Massachusetts.